The last problem in this section has to do with a hot air balloon that a person is measuring the height at different time intervals. Now, X is representing the number of minutes after the pilot started her stopwatch. Y is representing the height of that hot air balloon. Now, here we have an equation y minus 160 equals 40 x minus 1. And notice that this is in point slope form, so we are given the height of 160, and that corresponds to a time of 1 minute. Now the 40 is the slope of this situation. And it's saying that the hot air balloon must be rising because that slope is positive. And if the height is in feet and the time is in minutes, our slope will be in feet per minute. So it is rising at a rate of 40 feet per minute. Now part C, it says, what is the height of the balloon when the pilot started her stopwatch? Starting her stopwatch would be at a time of 0. So I'm going to take this equation of y minus 160 and I'm going to rewrite it so that I have it in slope-intercept form. And this would be y equals 40x plus 120. Now, if x is 0, from our time being 0, then we would get a height of 120 feet. Now, we're using x for time, but I wrote t equals 0 because usually when we talk about time, we'll use the variable t. But in this problem, they chose to use x. Now, another way to think about this problem is that at 1 second, it's a height of 160. But we know the slope is 40 feet per minute. So that means that 1 second earlier, this would be 0, and this would be 120. So we can also think of our answer in terms of just subtracting 40 because it was 1 second earlier.